Let's go for Unit 4, Section 2 for 2026 January paper. If you take question number 9 says, which concentration of aqueous calcium hydroxide has pH of 12.32? So they have given us the pH value. pH value equals 12.32, right? So it's calcium hydroxide. Calcium hydroxide is a base. When you hear about the hydroxide, that means they are talking about OH minus sign. So therefore calcium hydroxide is base. So they want to find the concentration. So find the concentration of a base. Best thing you should find the concentration of OH minus sign. That's what you have to search for. Right, but I have pH value. You know what is pH? pH means is simply minus log H plus sign concentration. But I need to find OH minus sign concentration. There's an equation at 25 degrees Celsius. If they haven't given you a temperature, it is 25 degrees Celsius. Remember that one in your Excel. At 25 degrees Celsius, they found this equation pH plus pOH is equal to 14. Actually, this 14 comes from pKW. That's why I told you the temperature, because KW at 25 degrees Celsius is minus log KW value is 1 into 10 to the power minus 14. Since it's 1 into 10 to the power minus KW is 1 into 10 to the power minus 14, pKW is minus log 1 into 10 to the power minus 14, it is 14. From there we learn that pH plus pOH at 25 degrees Celsius is equal to 14. So if I want to find the OH minus concentration, best thing is I'll find pOH. Okay, how to find pOH? pH plus pOH equals 14. No? pH value is given. So therefore pOH equals 14 minus the pH value, which is 12.32. And if you do the calculation, so pOH value equals, if you do the answer will be 1.68. But we know that what is this 1.68? So we know that the equation pOH equals, P means actually is minus log. So pH means minus log H plus sign. So pOH is minus log OH minus sign. So I have the pOH value. I want to find the OH minus sign. So what I'm going to do is I'm going to take antilog value of this minus 1.68. So how to find the OH minus concentration is simply one small thing you have to do. So it's better to get used to write this OH minus charge on top of the oxygen atom, right? I always do this mistake because I used to write OH minus, because if you put this minus charge on top of the oxygen atom, you will make minimum mistakes when you are drawing mechanisms. So that's why I always try to write the minus charge on top of the oxygen atom, because oxygen atom is the one who has that electron pair to have this minus charge. So we'll get back to our question. So I want to find the OH minus sign concentration. What you have to do is you have to take minus antilog of 1.68, and if you enter that value in the calculator, your answer will be 0.02089 moles per cubic decimeter. Okay, very good. You will get the answer. Your answer is here. Wait, it's not the answer. It's wrong. Why is that? The reason here is they are not talking about sodium hydroxide. They are talking about calcium hydroxide. If you take calcium hydroxide, its formula is calcium OH twice. So if you dissolve one calcium hydroxide, it gives you calcium 2 plus ion, but 2 OH minus ions. You get 2 OH minus. So that means if I have concentration of calcium hydroxide, let's say my concentration of calcium hydroxide is X, the concentration of OH minus ions I am going to get in the solution is 2x. But they're asking which concentration of calcium hydroxide. They need the concentration of calcium. That means they need the concentration X, not 2x. I found 2x here. That's the OH minus ion concentration. if 2x equals 0.02089, x will be half of that. So x will be 2089 divided by 2. So it will be 0.01. 0.01 means 1 into 10 to the power minus 2. So therefore my answer for question number 9 is B, not C, right? Remember that one. Right, let's go for question number 10. Question number 10. The structure of the sweetener aspartame. Okay, I also don't know about anything about this one. Let's see. Okay, they have given us some chemical formula. How many chiral carbon atoms are there in the molecules of aspartame? Okay, how many chiral? So we know what is a chiral system. Chiral molecule means if there's a carbon atom, to make it a chiral center, you have to have 4 different groups attached to there. If this is A, this group should be B. If this is B, this should be D. And if this is D, this should be E. 4 different groups. If a carbon atom has 4 different groups attached around it, we call it is a chiral carbon atom. So that means to have a chiral carbon atom, we need to have 4 bonds in the carbon atom. 4 separate groups to have a separate group. So you have to have 4 single bonds. So we'll forget about the molecules which has double bonds, because when they have double bonds, they can't have 4 single bonds. So I'll remove this carbon atom, this one, this carbon atom, and the carbon atoms in a benzene ring, we know that they have delocalized electron cloud, so it's something like partial double bond. So they can't have 4 bonds, they will only have 3 bonds. So I will remove all the carbon atoms in the benzene ring. So they cannot be my chiral carbon atom. So with that, I am left out with this carbon atom and this one and this one. Okay, yeah, and here also there's a carbon atom. So we need to have 4 different groups. I can see 2 bonds here. So if you don't see other 2 bonds in this carbon atom, that means they are hydrogen. We know that in the skeletal formula we don't do hydrogen atoms. So therefore, since this carbon atom has similar group, so this cannot be my answer. So I'm going to remove this carbon atom. This carbon atom also, there are 2 hydrogens. So it cannot be my answer. This carbon atom has 3 hydrogen atoms. So therefore, if you have similar group, 2 similar group, it cannot be your answer. So I just eradicate 3 carbon atoms. Now I am only left out with only 1 carbon atom. Now I don't need to check, because there's no answer calling 0 carbon atoms. So always they say either 1, 2, 3 and 4. So we have 4 options. We can see another carbon atom here. I missed that part. Okay, so now I have 2 carbon atoms left out. Let's take now those carbon atoms. Let's see whether they have 4 bonds. Okay, 1 bond here, 2nd bond here, 3rd bond here, and the 4th one they are not showing. That means it should be a hydrogen one. And here there's 1 bond, 2nd one, 3rd one, 4th one is a hydrogen atom. Okay, now we have 2 carbon atoms with 4 groups. Now let's see whether they are different from each other. So if you look at them, you can clearly see that this is, for this carbon there's a NH2 group, and this is a very long carbon group, and this is CH2COOH is a different group, and this is hydrogen. So this carbon atom has 4 different groups, so it is a chiral carbon. For this one also there's hydrogen, COOCH3, there's a CH2 and a benzene ring, and here NH and a long carbon chain. So therefore what will happen, this carbon atom also have a chiral center. Did we miss any other carbon atoms? No. So we have 2 chiral carbon atoms. So therefore my answer for question number 10A is B. Okay, let's go for question number 10B. Right, how many hydrogen atoms are there in the molecules of aspartame? For hydrogen atoms, I think we have to fill all the missing hydrogens. This carbon has, let's go one by one, otherwise I will miss just like the previous time. So this one has 1 hydrogen. Then this carbon doesn't have any more hydrogen because it has all 4 bonds. This carbon has 2 more hydrogens, so 1 plus 2 is 3. This carbon has one more hydrogen, 4, 5, 6. Here there are 2 hydrogens, so 5, 6. This carbon, no, it has all 4 bonds, 6. There's another one, 7. Here carbon, okay, 8. This carbon has no hydrogen. Here 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Alright, because this carbon has, because we know that in benzene ring they use one of the electron. You can think it like they are having some kind of double bonds. That's what the Kekulé said. So it's a delocalization is there. So therefore in benzene ring each carbon atom forms 3 bonds. So therefore this one has 3 bonds, but they have, you can only see 2 bonds. So that's the third one is hydrogen. So I will just count it. We are supposed to have 18 hydrogens. So therefore my answer for question number 10 part B is D. Okay. If you have any doubts on this structure of benzene, because I just told about thing is like having 3 double bonds. If you have any doubts, just leave a comment, then I'll discuss the structure of benzene separate. Like for now, just it's a separate structure, it's a different structure. They have delocalization. 6 electrons get delocalized and forming an electron cloud. That's what they have showing using this circle. Okay, so question number 10 part B, our answer is D. Right, let's go for question number 11. Okay, question number 11 has, okay, there are many sections. Let's see one by one. Section A, compound X has been detected in human red blood cells. Okay, the structure of X is shown. Which compound is shown when X react with lithium tetrahydroaluminate? This lithium tetrahydroaluminate means it's a reducing agent. So its formula will look like this: LiAlH4. Usually we add them in dry ether medium because this is highly reactive. So you have to have dry ether is a must as a condition, right? So when you add lithium tetrahydroaluminate 3, lithium tetrahydroaluminate 3 into this molecule, this is what will happen. This lithium tetrahydroaluminate has ability to reduce carbonyl groups. Carbonyl group means a molecule with carbon oxygen double bond. So what will happen when these carbonyl groups get, when you add lithium tetrahydroaluminate, this lithium tetrahydroaluminate will provide hydrogen atoms to do what? To reduce this carbonyl groups. So what happens here? 2 hydrogen atoms comes, 1 hydrogen atom goes here, making this oxygen atom into OH. So there will be single bond between the carbon atom and the oxygen atom. So if I'll put it down like somewhere here. So what it will look like is carbon atom is there. This oxygen will get 1 hydrogen and becomes OH. So since carbon need 4 bonds, the other hydrogen atoms will go from here and attach this carbon atom. So actually what they are doing here is, what this LiAlH4 is doing is reducing this carbonyl carbon into an alcohol. So therefore we have 2 carbonyl groups here, one and another one. So what will happen, both of them, they will get single bond. So what is the first thing you can see is this double bond disappears. There's no more double bonds, because and this each oxygen atom get hydrogen atom, so they become OH. But what will happen then, carbon has only 3 bonds. To make it the 4th bond, there's hydrogen atom comes here and there'll be hydrogen atom comes here. But we know that in the skeletal formula we don't draw those hydrogen atoms, so I just erase them. So this should be my structure when you add LiAlH4 in dry ether medium. So there's only one answer which shows that structure. So my answer for question number 11 part A is D. Right. Let's move on to question number 11, part B. Okay, structures of X is shown. Compound X oxidized under reflux to form compound Y. Okay, now they are going to oxidize this compound X under reflux. This is what will happen. So we can see when you're going to oxidize, usually we have alcohols and aldehydes. Aldehydes and alcohols can get oxidized. Let's see how it happens, right? So let's take, we have a primary alcohol here. If you have a primary alcohol, this is a primary alcohol. Oxidation means you add acidified potassium dichromate. So when you add acidified potassium dichromate, simply what happens, it will add oxygen atom. So it will add an oxygen atom. What this oxygen atom first going to do is, it will grab these two hydrogen and will form a water molecule. So what you are going to get here is, now those two hydrogen is gone. So this carbon left out with only one hydrogen. So there is an oxygen remaining. So it will form a double bond with that oxygen. So what I simply did was, actually this hydrogen was here, right? This is the hydrogen. So I just pen them up to make it look nice, right? The molecule. Okay, now we get the aldehyde. But it doesn't end. So we had the primary alcohol. First it became an aldehyde. Then it doesn't end there. There will be a further oxidation. Another oxygen atom jumps here. What this oxygen atom going to do? Because aldehyde, they don't end there. Because another oxygen atom jumps here. Then what will happen? This oxygen atom jumps in between this carbon and hydrogen. And what you are going to get here is carboxylic acid. Okay, so we get a carboxylic acid. Right. Now we have doubt. How do they get then aldehyde if you want? Because the reaction doesn't stop. It's keep on going. So it has actually two parts. We can call it, this section is the oxidation part. First reaction is the oxidation reaction. Second reaction is still oxidation. We call it further oxidation. Because oxidation will not stop there. It keeps on going for further oxidation. Now let's assume I want the aldehyde only. What I am going to do? I can do something here. Because can you see, in this primary alcohol and the carboxylic acid both has OH groups. In AS level you learn that molecules with OH group can form intermolecular hydrogen bonds. When you have hydrogen bonds, their boiling points are a little bit higher than you expect. That's why water is liquid. Water is a very small molecule. It's only 18 grams per mole molecular weight. But still, it's a liquid and it boils at 100 degrees Celsius. Why? Because of this intermolecular hydrogen bonds. But do you see that intermolecular hydrogen bonds here? No. It has only permanent dipole-dipole interactions. Therefore, when this aldehyde is formed, this aldehyde usually have a low boiling point than this primary alcohol and primary alcohol and carboxylic acid. So this one has a low boiling point. This low boiling point thing we can use to get this aldehyde out. How we are going to do it? Let's assume I have this primary alcohol and oxidizing agent in this pear-shaped flask. Now I'm going to heat it using the electric heater, right? Okay, so now this is my reaction mixer, it's heating. When the oxidation happens, what will happen? Our aldehyde will evaporate. Why? Because it has low boiling point. Aldehyde won't stay there, it will go out. Okay, now I have my aldehyde here. Then if I want this aldehyde, make sure you take it somewhere else. Take it out from that pear-shaped flask. How to do that? we can't let it go. So therefore what will happen? So we have the still head, there's a side arm, and we close the still head from here, and you put a thermometer, you check the boiling point. Otherwise, if the temperature is so high, even primary alcohol and carboxylic acid can also evaporate. Then what you do is we put a Liebig condenser. Liebig condenser is a like glass tube where there is cold water flowing through it. So always we take water in from the bottom and out from the top. You might be thinking, why always in from the bottom, water in from the bottom, water out from the top? The reason is, if you send water from the bottom till it completely fill, it won't overflow, right? It won't go out from the top. When it completely fill, only water will go out from here. So when you have water completely fill in this water jacket, the temperature inside this Liebig condenser low. So what will happen to our aldehyde? Aldehyde will condense, it will become liquid. You collect this liquid into a conical flask. Okay, so to make sure that, and what we do is we make sure that this liquid will get condensed. We put this connector here, edge of the Liebig condenser to the conical flask. But sometimes if our aldehyde does not condense properly, what will happen? Sometimes pressure might build up and there will be explosion. So therefore, to prevent that, we have a safety vent in this connector. There's a small hole. If the vapor didn't get condensed, they can leave from here, because safety is the first. Okay, so then we have aldehyde here. This is called simple distillation setup. So if you are doing simple distillation, we can get the aldehyde. Then some might say, if I want carboxylic acid, what should I do? If you want carboxylic acid, we know that, okay, we again have the pear shape plus we have the reaction mixture. And now what I'm going to do is I'm going to heat this reaction mixture. When I heat this reaction mixture, when the oxidation takes place, I get the aldehyde, and I know that aldehyde will start to evaporate because of its low boiling point. So, but if you want the carboxylic acid, you want to make sure that this aldehyde go down, react with this oxidizing mixture again. How I'm going to make sure that this aldehyde goes down? Simple. Use the same Liebig condenser, but you fix it vertically like this. Some might argue why we can't seal it from the top. You can't seal it from the top because pressure might build up and there will be explosions. So therefore what we do is, we let it go out, but we put this Liebig condenser. Since Liebig condenser has cold water around it, this area where this aldehyde is, where I have drawn the aldehyde, it will have very low temperature. Because of low temperature, it's a cold area, so aldehyde will condense down again into the reaction mixture. Therefore, this aldehyde will undergo further oxidation, producing the carboxylic acid. This second setup, we call it heat under reflux. Now, why I told all this one? Because they say here, it's oxidized under reflux condition, this one. So that means they made all of them for undergone further oxidation. Even you had the aldehyde, it will oxidize to a carboxylic acid. Do we have carboxylic acid? No, because there's another thing. They say they had PCl5, so we'll oxidize them to carboxylic acid first. So it doesn't matter whether you had aldehyde or primary alcohol, both will oxidize to carboxylic acid. So if I draw the structures, it goes like this. This one will turn into alcohol, will turn into carboxylic acid. That means I show this primary alcohol oxidized to carboxylic acid. This aldehyde will also oxidize to carboxylic acid. And this ketone will remain as it is. So both aldehyde groups and primary alcohol group turned into carboxylic acid. Now they say that which made the carboxylic acid, what we are going to do is we are going to add PCl5. When you add PCl5, what simply happen is OH group get replaced by a chlorine atom. So instead of OH group, I'm going to draw chlorine atoms there. So I need to find the structure which look like this. Yes. Okay, which structure looks like that is Is it? Yes, this one. Yes, that's the one which look like our product. So answer for question number 11B is C. Right. Let's go for next one. Question number 11 part C. Okay, there's section C. Which could be the low resolution proton NMR spectrum of X? Okay. So before I draw the low resolution proton NMR spectrum of X, I should first draw the displayed formula of this one. Because it's proton, I should see the hydrogen. So here there's one hydrogen. Then there's a carbon oxygen double bond. Then there's a CH2 group. And there's a OH group. Okay. So when you look at this one, I can see there are 1, 2, 3 environments of hydrogen. There are 3 types of hydrogen here. Hydrogen is in the 3 different environments, 3 different places. Since these 2 hydrogens are in the same environment, that's why I just put them together. Okay. So that means in my graph, there has to be 3 peaks, because 3 different hydrogen means 3 peaks. I know that this is another topic. It's very hard for you, like this NMR. Most of the students, they don't like it. If you have any doubts, leave a comment. I'll make a new recording on this lesson, NMR spectroscopy. Okay. So we have 3 environments. So therefore we have 3 hydrogens environments are there. So if we have 3 different hydrogen environment, we are supposed to have 3 different peaks. Okay, we have a problem. Why? We can't eradicate any of the answer with 3 different peaks, because all have 3 different peaks. So therefore we can't stick to that one. So we have to go with a different idea. Okay. So that's why I just took this NMR, this hydrogen nuclear magnetic NMR like spectroscopy. So it's like this spectroscopy shows us where this data shows us where each hydrogen environment appears. Okay, I'll take this one. I'll focus on this 2 hydrogen environment. This 2 hydrogen environment. Why that? That's the tallest one. Because number of hydrogen atoms in the given environment tells me the height of the peak. For an example, this one has only 1 hydrogen. That's why peak should be respect to 1. And this hydrogen also, there are 1 hydrogen. So therefore I should have 2 peaks with the same height. Yes, each one has 2 peaks with the same height. But this one has 2 hydrogens. So it should be twice taller than our other 2 peaks. Okay, where is that peak appears? It has a CH2 group attached to oxygen and carbonyl group. So I'm searching for hydrogen attached to oxygen and carbonyl carbon. Let's see how I can find that one, right? Hydrogen are here. Hydrogen attached to carbon and oxygen. Is there anything other than hydrogen attached to carbon? That carbon attached to carbonyl group. I found 2 matching environment. Here, if you take this peak, hydrogen attached to carbon, that carbon attached to oxygen. That means this range. And if you take the other one, hydrogen attached to carbon, attached to carbonyl. So if you see either side, these 2 are the ideal environment for them. Okay. That means my peak should be very close to 2 and 4. Okay. Other than 2 and 4 peaks, I'm going to remove them. This is not my answer. This is not my answer. Okay. This can be my answer between 2 and 4. This can be also my answer. In this one, C and D, you can see these 2 peaks are almost same. So I can only isolate from this peak. Okay. What is that peak? One is an aldehyde hydrogen. Okay. If it is aldehyde hydrogen, okay, now I'll show you this one. So now we end up with 1 hydrogen environment. It's this hydrogen. Aldehyde hydrogen is the one there. Okay. So if I take aldehyde hydrogen, can you see it should be in this area? So which means environment should be between 9 and 10. Okay, this peak is there, but this peak is a little bit further away. What is that one? Very close to it. It should be a carboxylic acid hydrogen. We don't have carboxylic acid here. This is a primary alcohol, ketone and aldehyde. So therefore, this peak tallies with my data and these two peaks also tallying with that. So therefore, my answer for question number 11C is D. Right. Let's go for question number 11, part D. What is the splitting pattern of the peak due to protons of CH2 groups in the high resolution proton NMR spectrum of X? Okay, again I have to draw the structure displayed formula because I don't have a memory like you because I am old. Okay, so I have to again draw it. C double bond oxygen, CH2, OH. Yeah, I lost this because I lost this memory part. I won't tell you that part because when we grow old, what will happen? Our brain cells get tired, but there's a way you can keep your memory also for a long period of time. I'll tell you how I'm going to do that one, but still let's work on this one. What is the splitting pattern of peak due to the proton of the CH2 group? They are talking about CH2 group, and there's in this CH2 group there's something called N+1 rule. It's like this. Now we know that they get 3 peaks. No, I'm not drawing in the right height, but let's assume this one gives you 1 peak, this hydrogen gives you 1 peak. Their height should be the same height because the reason is they have same number of hydrogen, and this peak should be give you a peak but which is twice taller than the other 2 peaks. Okay, but what will happen? Some peaks based on the adjacent carbon, if there are hydrogen atoms in the adjacent carbon, based on that one they will divide into sub peaks. For an example, if this 2 hydrogen peak, if it's going to divide into sub peaks, it depends on number of hydrogen atom in the adjacent carbon plus 1. For an example, if your adjacent carbon had, it doesn't have, if it had 1 hydrogen, so 1 plus 1 is 2, so this one will become 2 peaks instead of 1 peak. But we don't have hydrogen there, no. So when we don't have hydrogen means N is 0. Adjacent carbon has 0 hydrogen. 0 plus 1 is 1. So equal is single. 1 means 1, right? Is singled. So the peak which has only 1 sub peak equal is singlet. So therefore answer for question number 11, part D is A. Alright. Let's go for question number 12. The structure of compound Z is shown. How many peaks are there in C13 NMR spectrum of Z? C13 NMR spectrum means how many types of carbon is there. That's what they are calling. Right. Let's try to answer this one. Okay, first of all, I'll draw this structure. No? Okay, I'll draw this structure. So we have OH group. Right. Then we have a CH2. Okay, just carefully observe the colors I'm using, right? There's red color carbon, CH2. Then that carbon is attached to a, okay, there's a hexagon. So we have carbon here, and that carbon, there are only 3 bonds now, we can see. So it has hydrogen. I just draw the hydrogen here. So I will use the same black color. So I have hydrogen here. Then I'll draw the hexagon. So we have hexagon. Right. I'm not going to draw the hydrogen in that hexagon, but see the color I'm using. I'm going to use this carbon here and put hydrogen, and next one we have OH, hydrogen, hydrogen. Why I put this carbon is in red color as well as this one? Can you just look around them? Can you see they are just like a mirror, like you are just looking at yourself in a mirror? They have the same environment. OH, 2 hydrogen, OH, 2 hydrogen, CH, hexagon, CH, hexagon. Why I drew this carbon in green color as same as this carbon? Can you see? It's the same environment. CH, part of the hexagon, CH, part of the hexagon. One side is CH2OH, this side also CH2OH. Now let's go for this ring. Okay. So let's assume I can mark this carbon and this carbon in the same color, because you know that they have similar structure, because similar background. And this carbon, those two also have similar structure. So therefore, we can say it has, see the colors 1, 2, 3, 4 types of carbon. So that means in C30 NMR spectrum, you get 4 peaks wrong, no marks. Why is that? The reason is that's the point they want to check. This pink color, I have to erase it. Why? Because can you see the blue color environment is same as this pink color environment? Are you sure? Let's check. Carbon atom here, hydrogen, 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 hydrogen. I'll take 2 carbon atom. I'll show that they are equal, right? So let's take this carbon atom. It has 2 hydrogen. This carbon atom also has 2 hydrogens. So same. And this carbon atom, this side is CH, CH2OH. This side also CH, CH2OH. And the other side is a carbon atom which has CH2, CH, CH2OH. And for this one also, carbon atom is CH2, CH, CH2OH. And the round also same. So if these two environments are same, so you can see that these two also have the same environment. So therefore, the colors I have is, types I have is red color carbon, a green color carbon here, 4 blue color carbon atoms. That's it. Red, green, blue. Only 3 types of carbon atoms I have in this structure. Therefore, question number 12, section A, my answer is A. That's what they expect to see. They were trying to mix you up. So most of you, like most of the time, if you don't identify that part, you will mark answer B. Right, question number 12, part B. The diol reacts with ethanoic acid. A diol means this molecule is 2OH group. Ethane dioic acid to form polyester. What is the structure of the repeat unit of polyester? Okay, I'll just first do that one for you. This is the diol. Diol means it has 2 OH groups. I just expand this OH group. Okay, with ethane dioic acid. Ethane dioic acid means you have 2 carbon molecules, so there are just two dots, and those are carboxylic acid. Okay, so this is also double bond oxygen and OH group. So I'll draw another set of molecules like that. So I'll draw another diol. So OH, and another carboxylic acid, dioic acid. Sorry, it should be in red color. Okay, here you have OH, carbonyl group, OH. So this is what happens when they try to form ester bonds, what simply happens, OH group from the carboxylic acid goes with the hydrogen atom of the alcohol. OH group of the carboxylic acid goes with the hydrogen atom of the alcohol. They will form water molecules. Here also they are going to form water molecules. And here also OH group from the carboxylic acid goes with hydrogen atom of the alcohol. They will leave the system as a water molecule. Here also OH group from the previous carboxylic acid goes with this hydrogen atom forming a water molecule. Same thing happens here. So after I remove this formation of water molecules, let's see what's remaining here. Let's draw what's remaining here. So after this condensation, what you get here is, now here, so oxygen atom is remaining. Hexagon. Oxygen. The linking bond, I just show it in a different color, right? Then we have carbonyl group. The linking bond, yes, is fine. See it? So right there. Again, there's a linking bond. I'll use a green color for linking bond because otherwise it's very hard to distinguish the colors. Okay, yeah, that's, you can see clearly. And it's linked to this oxygen again. Again, we'll link them together. Again, carbonyl group, another carbonyl group, and the bond. Okay, so what will happen? So this is our finally the polymer. They're asking, what is the structure of the repeat unit? Can you see this black and red group keep on repeating again and again? So this black and red group keep on repeating and again. So if I want to find the repeat unit, what I'm going to do is, I'm going to take the beginning of the black group to the red group. So can you see again the same group, black and red keep on repeating again and again. So this is my repeat unit. Let's see where I can find such structure. Okay, so you should start your repeat unit from an oxygen atom. There are only two structures which start from oxygen atom. And here, okay, it's look fine. Oxygen, carbon, but it never ends with another oxygen because this black part is in the next repeat unit. So there's another oxygen atom they have added. That's wrong because it should end with this carbonyl group. No? So here oxygen atom starts. This group is there, fine. Ring structure is there, fine. Oxygen atom is there. Carbonyl group is there. The second carbonyl group is there. End of the repeating unit. So therefore my answer for question number 12 part B is A. Okay, we finish the MCQ part of this paper. Right. Now I'll tell you one problem you will have here is when you work on your exams and when you put your more effort, there'll be what will happen to your brain is your brain cells will get burnt out. It's something like this. Usually in our brain, the nerve cell get replaced. So if you want to have good memory, if you want to have good cognitive understanding, the best thing is if you want to have more cognitive ability, logical thinking, you have to make sure that your new neurons are produced again and again. So this process of producing new neurons in your brain, we call it neurogenesis. Right? It's something like this. We have to do two things. One is we have to have neurogenesis, then you have neuroplasticity. For an example, if you know how to drive, you can think about the way you drive or the way think about the day. First you learn how to ride a bicycle. When you're riding bicycle or when you're driving, for each and every step, your brain is keep on thinking. When you're turning a bend in a bicycle, what will happen? Your brain is thinking how much I should turn this handle. And when you're turning a bend in a vehicle, your brain is thinking how much I should turn my steering wheel. So, and while you are driving, if you are driving a manual vehicle, each and every step, you have to think. Your brain is keep on thinking. What it's going to do is, Then after you learn to ride the bicycle or learn how to drive the vehicle, then when you do it like for like 1 month or 2 months, then you never think you can do it while doing something else. While eating, you can ride your bicycle, while listening to music. Why is that? Because your neurons are adjust into do a certain function. We call it neuroplasticity. Before going for neuroplasticity, we need to have more and more neurons produced, new nerve cells produced inside your brain. So they have found that researchers, you can increase the neurogenesis up to 5 times than normal person. So that will help you to have a better memory. I'll tell you few few things, exercises you can do. I'll share more exercises in my next videos. I'll tell you like only 4 exercises for now you to do to have a better neurogenesis. First thing is, we call it sensory immersion. That means, now go to your room, and then what you're going to do is you close your eyes and try to walk around the room. Or what you can do is, when you're having a bath, when you take a bath, close your eyes throughout the time that you're going to have a bath. Try to make sure that where is the shampoo bottle is, where's the soap is, and where's the tap is, and how to adjust the temperature. So all these things you have to do it. Do it like at least once a week. By doing this one, what will happen? Your neurons will try to analyze and try to waken up the nerve cells which did not use for certain functions. So therefore, what will happen? Their sharpness of your thinking and spatial awareness will increase. Second thing you can do is navigation. You can get into the vehicle, or you can use, like while you are using laptop, you can try this one. You try to go through each and every, locate the controls. If you are in a vehicle, how to open the door, what are the signal lights, how to turn on the wipers, and everything. Just touch them, try to make a sense. Okay, make sure that you never drive the vehicle while your eyes are closed, right? You have to do all these things when your eyes is closed. It will improve your neurogenesis. The second thing is non-dominant hand challenge, which means what you're going to do is, what you used to do if you are right-handed. Let's assume you used to brush teeth using a right hand. For at least once a week, try to brush your teeth using left hand. So when you keep on doing this one, again it will influence or enhance your neurogenesis. There's another one. You can do this using mirror writing or using the opposite. Let's assume if you are a right-handed, use your left hand. If you are left-handed, use your right hand, at least to write 1 page per week. Or what you can do is, you can place a mirror in front of you and keep a paper take a paper in front of you. Then what you're going to do is, you are going to write something on this paper. So let's take this is the paper. You are right, but you are not directly looking at the paper. You look at the mirror, and from the mirror reflection, you try to write the words properly. Try to do that one. Try these 4 exercises at least once a week. It will improve your neurogenesis. That's good for improve your memory. Okay, we finished now 2026 January Unit 4 MCQ section. So if you have any doubts, if you want any subject part or like theory part for me to explain in a different video, what you have to do is just leave a comment in this video. Thank you.